Okay, we had a whole chapter about triangle congruence, and if you remember, we had a bunch of triangle congruence theorems and things like side, 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 side angle side, and hypotenuse leg. If you remember those kind of congruence theorems. Well, today we're going to talk about triangle similarity, and there are basically three. There's one postulate, the angle postulate, okay, which I'm going to explain in a moment. And then we have two theorems, a side, side, side theorem and the side angle side theorem. Okay, and we're going to show you an example of each one of those. In fact, let's start here. Now, look at these two triangles. The question is, are these two triangles congruent? Excuse me, similar. I keep saying congruent. Are the two triangles similar? Well, if we look at you see this is 35 degrees here, but we don't know what angle N is. Okay, angle L corresponds to angle N, and we know angle L is 35 degrees, but we don't know if the corresponding angle is 35 degrees. So basically, we know that angle K and angle M are congruent because they're both right angles. So let's take a look. If you've got angle K is 90 degrees, if you've got two angles, 90 plus 35, looking at this one, that equals 125. And of course, if we subtract that from 180, we get 55 degrees. And so this angle is 55 degrees. Angle J is 55 degrees. And of course, if this is 55 degrees, then angle N must be 35 degrees. And so if we have the two angle measures from each triangle, we can find the third angle measure, and we can find out if the corresponding angles are congruent. And remember, if the corresponding angles are congruent, then the two triangles are congruent. And so that's what the angle postulate is all about. And we'll have a chance to apply that. So here's another one here. What about side, side, side postulate? Now remember, the sides are not going to be congruent. They're going to be similar. And so let's take a look at these sides. Now, RQ corresponds to TU, so we say 4 over 2.4. And if we divide that using our calculator, which I'm going to magically make appear on my screen, 4 divided by 2.4 is 1.6666, so it looks like 5/3, doesn't it? Or if you rather, let's just call it 1.67, okay? So this is approximately 1.67. In other words, 1.666 rounded off. And then let's look at the next one, 7, and the other two are the same. So if we just do that one time, we'll know. So 7 over 4.2. 7 over 4.2. And let's see if that's going to be the same. And 7 divided by 4.2, and that looks like it's the same thing, 1.67 rounded off. Okay, so that's equal to 1.67. Now, if this is 7 over 4.2, this side is equal to 1.67, then this is going to be the same. So since all sides have the same ratio, that means, according to the side, side, side postulate, then these two triangles are similar. Okay? And we have one more here. And you notice that we have 25-degree angle here, 25-degree angle here. I don't know what these two angles are. I don't know what these two angles are. But I've got a side here. Let's make the side 2 over 3. Well, that's pretty clear, 2/3. And what about 3.6, okay, this one here, over 5.4. Well, if I divide the top and bottom by 1.8, then I get 2. If I divide the bottom by 1.8 divided by 1.8, I'm going to get 3. And so the ratio of the two sides is 2 to 2/3. Okay? And the angle in between is the same. Notice it's the included angle. Just like before when we had side angle side, we have to have the included angle. So what we have here is a side angle side. Oops, did I say postulate? I'm supposed to say theorem because this is a theorem, not a postulate. Theorem. And this other one up here is not a postulate. This one is also a theorem. But, and this is a theorem, but the angle is a postulate. Okay? And don't ask me why. Just do your practice problems. And the practice is on page 520, 6, and 8. Your homework is going to be page 521, 8 through 24, even. And that's all I got to say for you today, and it only took less than 7 minutes. I think I'm doing pretty darn good. Thanks. Bye.